Good morning, students. In today's class, I will be explaining some of the basic concept you should know in order to understand the process scheduling concept. What do you mean by process scheduling? When several processes are waiting for the CPU, which process should be given the CPU first, or which process will be serviced by the CPU first. So that is decided by one algorithm. That algorithm which allocates the CPU to one of the job which are all waiting, we call it as a scheduler. So scheduling is a process of allocating the CPU to the waiting process, and the program which does this task, we call it as a scheduler. So in today's class, I will be discussing about basic concept of process scheduling. In our previous class, we learned about the basic concept of process. What is a process? A process is nothing but a program in execution, which is an active entity when compared to a job or a program which is passive in nature. Any process, if it wants to execute, it requires some resources. When the resources are provided to the process, then the process executes successfully. Any process during its lifetime undergoes several states. So these states are called as process state. When the process is created or submitted, it is said to be in a new state. From the new state, a process next goes to another state called ready state. Ready state means it is just waiting for the CPU. It has completed all its remaining work and it just simply it is waiting for the CPU. In that case, the process is said to be in a ready state. Once the CPU start executing that process, it goes to another state called running state. But during the process execution, sometime in between, the process needs some IO operation. The process requires some IO operation. In that case, from the running state, the process moves to another state called waiting state. Why it is waiting, goes to waiting state means whenever the process has an IO operation, the IO operation is generally serviced by the input-output devices. But the process sends an IO request. At that time, a particular IO device may not be free. So in that case, the process has to wait till the IO device becomes free. Once the IO device becomes free means then the process will be serviced by the corresponding IO device. After that, once again, the process goes to ready state, because from the waiting state, if it goes to ready state, why means the process may not get the CPU immediately because the CPU may be busy in executing some other program. So again, after some time, it goes to running state. After completing its execution, the process goes to terminating state. The complete information about a process need to be maintained. That is maintained by means of a special data structure called process control block. So these concepts we have studied in our previous lesson or previous session. In today's class, we will be discussing about fundamental concept of process scheduling. What are the different types of queues that comes into picture when during process scheduling process, and what is a scheduler, what is the basic function of a scheduler, and what are all the different types of scheduler and the functions of each of these schedulers. At the end of today's class, you will be understanding the basic concept of process scheduling. You will also understand what are all the different types of queues available for process management and the basic functions of a scheduler and different types of scheduler, and also the role of each of these schedulers. In our previous classes, we learned about two basic types of operating system called multi-programming operating system and time-sharing operating system. In a multi-programming operating system, instead of one program, several programs are loaded into the main memory. Then the CPU start executing the process one by one. First, it takes the process P1, execute. Then after executing, it goes to process 2. After executing P2, it goes to the next process in one particular order. But only if any process has an IO operation, in that case, the CPU start executing the next process in the queue. So here, if wherever any process is available, the CPU never sit idle, because when first process has any IO operation, it goes to second one. When second has an IO operation, it will not wait. It goes to the third process. When the third process has no IO operation, means it will execute that process completely. Then after executing all the process which are there in the main memory, then it comes back to the first process, checks whether by this time, whether the process has completed its IO operation. If it has completed, then start executing from the point where it left earlier. So like that, as long as some job or some programs are available in the main memory, your CPU will not sit idle. So you will giving maximum work to the CPU. So we are getting maximum CPU utilization in multi-programming. That is the main reason behind the creation of multi-programming concept. The only problem with multi-programming is the waiting time will not be same for all the process. If the first process has no IO operation, means then the second process has to wait till the completion of the first process. If the first two processes have no IO operation, means that the third process has to wait till the completion of previous two. So like that, what happens is the process which is at the end of the queue has to wait till all the previous process have been completely executed by the CPU. Due to this reason, they developed the concept of time sharing process. In the time sharing process, the CPU is shared among several processes in the memory. The CPU will not execute any process completely. It will execute every process in the memory only for a one time quantum duration. After that, it will go to the next process in the queue. Then they execute that process also for one time quantum. Then move to the next process, etc. Once all the process in the main memory gets the CPU for one time quantum, then it will execute again all the process for second turn for one quantum time of time. So here what happens is, as far as possible, we are getting maximum CPU utilization. At the same time, the waiting time is also more or less will be uniform in case of time sharing system. For a uniprocessor system, as the name indicates, there will be only one process running at any time. But these concept, the process scheduling concept comes only if there are more processes. If there are more than one process, then at any moment, only one process will be executed by the CPU. All the remaining process has to wait till the CPU become free. So some program has to be designed. That program takes care of allocating the CPU to one of the process in the main memory. So which process should be given the CPU first, which process will be given the CPU next, etc. All these things are decided by that program. That program we call it a scheduler. In any process management, different types of queues are useful. The different types of queues which are useful in any process management are of three types. One is job queue. A job queue is one. See, if there are 100 programs to be executed, if there are 100 programs or 100 programs are to be executed, means all the 100 programs we can't bring it to the primary memory at a time, because in every computer there is a limited capacity of main memory, because main memory is an expensive resource. So you cannot keep on increasing the main memory capacity. So all the process which needs to be executed first enter the system, and they are made to wait in one queue. The queue where all the jobs which are waiting for the CPU or which need to be serviced is called a job queue. So all the process first enters the job queue. Suppose in a class, if there are some 100 students and each student has written one program, then in that case what happens is we have 100 programs. All the 100 programs first made to wait in one queue. That queue where initially all the processes are waiting, we call it a job queue. But now what happens is, depending on your main memory capacity, suppose if your main memory can accommodate only 5 programs at a time, in that case what happens is, out of the 100 program in the job queue, any 5 program should be transferred from the job queue to another queue. So that queue we call it a ready queue. A ready queue is one where the process waiting to be executed. That means in a ready queue, all the process which have already completed the IO operation, they are simply waiting for the CPU. Only those programs are in the ready queue. So from the job queue, depending on the size of your memory or depending on the capacity of your main memory, some 5 need not be 5. It depends on the main memory capacity. If your main memory is capable of loading 10 programs at a time, then out of the available program in the job queue, some selected job are transferred from the job queue to the next queue called ready queue. Then what happens is, now all the program which are in the ready queue to be serviced by the CPU one by one. The CPU start executing the program one in the ready queue, execute it, then goes to second one, then goes to third one, then goes to fourth one, then goes to fifth one. If now what happens after executing, after completely executing all the program in the ready queue, next what happens? Next set of program are brought from the job queue to the ready queue. Again, in the ready queue, the jobs are serviced by the CPU one by one. But in between, if any process which is currently under execution by the CPU has any input output operation, IO required, in that case, that program will not be allowed to stay in the ready queue. Assume that the first program needs the printer service. In that case, immediately that job is removed from the ready queue and it is moved to another queue called printer queue. So printer is one device, so that's called as a printer device queue. Then automatically the CPU start executing the second process or second program in the ready queue. Suppose that program also needs some printer service. In that case, what happens is that program is also removed from the ready queue and made to join the queue where all the program which are waiting for the printer. Now what happens is your printer queue has two programs, P1 and P2. Then the CPU start executing the third program in the ready queue. So depending on here, what happens is any job has any IO operation means then that program is removed from the ready queue and it is made to join the third type of queue called device queue. So depending on, for every device, there is one separate queue. For printer, there is a printer queue. For scanner, there is a scanner queue. For speaker, there may be another device queue. So depending on the different input output devices, we have a separate queue for each and every device. So probably you have understood. A job queue is one where when the moment the process enters the system, first it is made to stand in the first queue, the job. So job queue is a very lengthy queue because all the program first goes to job queue. Now, depending on the capacity of your main memory, some selected job are transferred or moved from the job queue to the ready queue. Now, the CPU execute only those jobs which are in the ready queue. Now, after executing all the program in the ready queue, then another set of jobs are moved from the job queue to the ready queue. So, now what happens is, if any of the program in the job queue has any IO operation, in that case, it is moved from the ready queue to the device queue. Now, then whenever the device becomes free, then the particular device service all the program which are waiting for that particular device. Suppose there are 3 programs which are waiting for the printer, means whenever the printer becomes free, because in your system only one printer is there, means whenever the printer becomes free means then the printer also service the 3 programs which are waiting for that device one by one. Now, after that, again, the cycle repeats. Next set of jobs, set of programs are brought from the job queue to the ready queue. After executing all the program in the ready queue, if there are no IO operation, means your device queue will be completely empty. Because if none of the device in the ready queue has any IO operation, means all your device queue will be completely empty. So this is the role of different types of queue in any scheduling algorithm or scheduling policies. Already explained what is a scheduler. A scheduler is nothing but a program which task is to move the job from one place to another place. Then one scheduler moves the job from job queue to ready queue. Another job scheduler moves the job from ready queue to the CPU, and like that. So during the lifetime, a process switches between various scheduling queues. It is a responsibility of the operating system to select a process for scheduling purpose. So one scheduler decides which set of program should be brought from the job queue to the ready queue. Another scheduler decides out of the program or out of the process in the ready queue, which process has to be executed by the CPU first, which process has to be executed by the CPU next, etc. So this scheduler is a program which performs the task of selection of process. Selection of the process means selecting the program from the job queue to ready queue, or selecting the process in the ready queue and allocate it to the CPU. These two are the functions of the scheduler. So basically, we have 3 different types of scheduler called as long-term scheduler, short-term scheduler, and medium-term scheduler. To understand the concept of long-term scheduler, and short-term scheduler, we can consider this as an example. Assume that from your first standard till your final year BSc, you have purchased some 100 books. Then where you keep all your 100 books, you may keep in your Almera. So your Almera, we call it as a job queue. Then when you are in first year, then what happens is, out of 50 books or out of 100 books which are in the library, then we bring some program we bring some books which are useful only for first year and keep it on my table. Now what happens is, now for the entire year, you refer only those books which are available on your table. Then what happens, after reading all the books, completing your first year, then what we'll do is, we'll move those programs from the table. We may put it back to Almera and bring back next set of 5 or 10 books which are required for second year. Now, for the whole year, you refer only the books which are there in the table. Then after completing the second year, then we bring the books which are there in the Almera, which is useful for your final year, and bring it on your table. So here what happens is, the Almera is an example for job queue. Your table is an example for which one? Your table is an example for ready queue, and your brain is an example for CPU. Because in your final year, you service or you refer only those books which are there in the library on our table which are useful for final year. The last one is medium-term schedule. Sometimes what happens is, sometimes we need to exchange the book from that Almera to the table. One book has to be transferred from one place to another place. So the process we call it as a swapping. So swapping will make use of another type of scheduler. Anyway, I will explaining the function of each of these 3 scheduler in my next slide. A long-term scheduler. A long-term scheduler main function is to move the job from the job pool to the main memory. Another name for a long-term scheduler is job scheduler. That's all. In your, suppose there are 100 programs which need to be executed by the CPU. Definitely, we cannot bring all the 100 programs simultaneously into the main memory. Then your long-term scheduler identify which set of program has to be moved from the job queue to the ready queue. Because your CPU can execute the program only if it is in ready queue. CPU will not execute the job directly from the job. So a long-term scheduler function is to decide which set of program to be brought from the job queue to the ready queue. Hence, it is called a job scheduler. A short-term scheduler is one. A short-term scheduler select the process which are there in the ready queue and allocate the CPU to one of the program there. Because if your ready queue right now consists of 5 job or 5 program or 5 process means, then out of those 5 programs, CPU can execute only one. So which should be given the CPU first? That is decided by a short-term scheduler. Hence, a short-term scheduler, we also call it a CPU scheduler. The basic difference between a long-term scheduler and a short-term scheduler is, long-term scheduler, what it will do is, it will bring some set of program from the job queue to the ready queue. Now, unless and until all the programs in the ready queue are completely executed by the CPU, your long-term scheduler has no work at all. Because the next work for the job long-term scheduler stop only after the ready queue becomes empty. Only after all the programs in the ready queue are completely executed by the CPU. Till the time CPU takes to execute all the 5 programs, your job scheduler does not have any other work. But the short-term scheduler must be very, very fast, because CPU is very, very fast. So what happens is, CPU take the first program in the ready queue, execute within a millisecond, some millisecond, 20 milliseconds. Immediately, the short-term scheduler has to decide which program should be given the CPU next. Because assume that your ready queue consisting of 5 programs, P1, P2, P3, P4, P5. Now what happens is, whether the CPU should be given to the P1 first, or P2 first, or P3 first, or P4 or P5, that is decided by the short-term scheduler. Assume that the short-term scheduler decides P3 is high priority job. Then what it will do is, it will allocate the CPU to P3. After executing P3, then the short-term scheduler has to decide which should be given the CPU next. So here what happens is, since the CPU execute any job within some millisecond, immediately short-term scheduler gets the next work to decide which program or which job should be allocated to the CPU. So that's the reason short-term scheduler should work very fast when compared to long-term scheduler. In the case of long-term scheduler, what happens is once some jobs are brought from the job queue to the ready queue, until all the programs in the ready queue are completely executed, long-term scheduler does not have any other work. So similarly, the frequency is also very much high for short-term scheduler compared to long-term scheduler. Suppose there are 100 jobs, and assume that your ready queue can accommodate 10 jobs. In that case, what happens is first 10 set programs are brought from job queue to ready queue. Next set of 10 programs are brought from job queue to ready queue. So in that case, what happens is your long-term scheduler works 10 times, because at a time it can transfer 10 programs from the job queue to the ready queue. So the frequency of work for the long-term scheduler is only 10. Once in 10 program, it has to work. Whereas in the case of short-term scheduler, what happens is first send 10 programs if it is available in the ready queue, means then the short-term scheduler go from P1, then first allocate P1 CPU to P1, then to P2, then to P3, then to P4, then to up to P10. So now short-term scheduler have 10 different works. Then after that, next set of programs are brought from the job queue to the ready queue. Again, if it is 10 job means, again your short-term scheduler work for 10 times. So actually, a short-term scheduler altogether, it will work for 100 times. So hence, the frequency of operation is more for short-term scheduler when compared to long-term scheduler. And also, the short-term scheduler must be very, very fast, because a short-term scheduler has to work with the speed of CPU. Immediately after CPU completely execute one job, immediately short-term scheduler has to decide which should be given the CPU next. So it has to work on par with the speed of the CPU. Whereas long-term scheduler is not like that. First, it moves some set of jobs from the job queue, push it into ready queue. Then till that time, it will keep quiet. Mid-term scheduler. Sometimes what happens is your CPU is executing one of the job from in the ready queue. All of a sudden, a high priority jobs comes. In that case, CPU has to stop executing the job which is currently executing, pick up the high priority job. After the high priority job is completely executed, then it has to pick up the job which has left earlier. So in that case, we need to, because CPU can execute only one job at a time. The CPU currently executing, assume that the CPU is executing P1. All of a sudden, a new program comes whose priority is higher than P1. In that case, P1 has to be moved to some place. It has to accept the high priority job, execute it completely. Then it has to receive back the program P1 because it has been interrupted. So in that case, we need to exchange the program. A high priority program has to be swapped with the currently executing program. So the swapping is done by a medium-term scheduler. So in any CPU scheduling, these three schedulers are very, very important. One is long-term, hence the name is called long-term, short-term, and medium-term. Why it's called short-term? It will get the work within a short period of time. A long-term scheduler will get the work after a very long time. After once 10 jobs are made, only after executing 10 jobs only, it will get the next one. Any program you take, it is considered as CPU bound job and IO bound job. Any program which require maximum CPU time, it is considered as a CPU bound job. There are some jobs where the CPU time is less compared to IO time. So that program or that job makes use of maximum input output devices than CPU. Such jobs are called as IO bound job. Any job which needs maximum CPU time and less IO time is CPU bound. Reverse is the job which needs maximum input output time and less CPU time is IO bound jobs. But if you want to get the maximum output, if you want to get the maximum utilization, you should have a mixture of both the jobs. What happens is, if all the jobs are completely CPU bound jobs, means then there is no work for your input output devices. In that case, your device queue will be completely empty, because no program is requesting any input output devices, means your device queue will be completely empty. Sometimes what happens is, some jobs are 100% IO bound job. If all the jobs are IO bound job, means all the jobs has to go to only device queue only. In that case, your ready queue will be empty. So it's not a good practice to have only completely CPU bound job or completely IO bound job. If you have a mixture of both in a ready queue, if you have some job which are CPU bound and some job which are IO bound job, means then what happens is your CPU will also get some work, your IO device also will get some work. Means you are utilizing the for performance of you are utilizing both CPU as well as the input output device to the best possible way. So you will have better utilization of both CPU and input output devices. So therefore, bringing the program from the job queue to the ready queue, definitely we know it's a responsibility of a long-term scheduler. So long-term scheduler first has to identify out of the jobs available in the job queue, it has to pick up the job in such a way that when some jobs must be CPU bound and some jobs must be IO bound, then make that group, then bring that group into the ready queue. So it's a responsibility of a long-term scheduler to select a good mixture of input IO bound jobs as well as CPU bound job for better utilization of CPU as well as input output device. Next, a job amount the time it spent for execution by the CPU, we call it as CPU burst time. The time it spends waiting for the input output device plus the time it utilizes the services of the input output device, we call it as IO burst time. Any job you take, suppose there is a job called P1 or there's a program called P1. Suppose that program takes 10 seconds. In that case, what happens is, suppose first 2 seconds it is CPU, then next 3 seconds it is IO job, then once again come back, it will execute by the CPU for some time. In that case, what happens is your entire job execution starts first with the CPU burst. The CPU burst means the time it spends executing by the CPU. Suppose that particular job has any IO operation, then immediately it has to go to the device to wait there till the IO device becomes free. Then the IO device will utilize the service of the IO device. So that time we call it as IO burst time. Then after the IO request is over, once again it executed by the CPU. Again it goes to the next CPU burst. Then it may goes to IO burst, CPU burst, IO burst. For any job, it's a cycle of CPU burst time and IO burst time. But for any job, the first it starts with the CPU burst time and ends with CPU burst only. In between, you can have either CPU burst time or IO burst time. Suppose the program is 100% CPU bound job. That means there is no input output operation. Then the entire program execution is just a cycle of only CPU burst. Suppose there are some jobs which are maximum IO bound job. To start with, it will go to CPU burst. After that, it's a complete cycle of only IO burst. Finally, before going to the termination state, it first go to CPU burst. So any job execution start with CPU burst, ends with CPU burst. In between, you can have any cycle, any number of CPU burst and IO burst cycle, or CPU burst and IO burst time. Students, in today's class, I explained some of the basic concept behind CPU scheduling. Then what do you mean by CPU scheduling? What are the different types of CPU schedulers, long-term, short-term, and medium-term? What are the different types of queues, such as job queue, then ready queue, device queue? What is the function or role of each of these queues? What is the function or role of the different types of scheduler? So definitely, you should remember always, long-term scheduler function is to move the program from job queue to ready queue. That's all. The short-term scheduler function is to decide out of the program in the ready queue which should be given the first, which should be given the CPU first, which should be given the CPU next, etc. And the medium-term scheduler functions come only in case of swapping. Your CPU is executing some job, all of a sudden some new jobs come whose priority is more than the currently executing job. In that case, this program has to be moved to some place, probably secondary memory, then brings that program, execute that program. After the execution is over, it will bring the program from the secondary memory back to the ready queue and start executing. So during swapping operation, your medium term scheduler work comes. So these are some of the review questions. What is a scheduler? Mention the different types of scheduler. What are the functions of different scheduler, etc. Write the difference between long-term scheduler and short-term scheduler. Distinguish between IO bound and CPU bound. Any job which require maximum CPU time is CPU1, which require maximum IO time is IO1. Mention the different types of queues used in CPU scheduling. Some interesting multiple choice questions on today's class. A long-term scheduler is also known as job scheduler. The correct answer is B. Which of the following scheduler must be fast? Is very fast. Definitely, we know that one. A short-term scheduler has to work with the speed of CPU means that must be faster than the long-term scheduler. The correct answer is C. Which of the following queue will be empty for 100% IO bound job? If all the jobs are 100 IO bound jobs, your ready queue will be empty. On the reverse, if all the jobs are CPU bound jobs, your device queue will be empty. The correct answer is for 100% IO bound job, which is your ready queue is empty. During swapping operation, dash scheduler works medium term. Jobs waiting for the CPU will wait in dash queue. So only job which needs to be executed by the CPU first must be brought from the job queue to the ready queue only. So because your CPU execute only those jobs which are available in the ready queue. So the correct answer is okay, students. I will wind up my class today. If you have any doubts, you can ask me either through my mobile number or through my email ID or posting your queries in the comment section. Okay, thank you.